Okay guys, so you were asked to solve these problems on page 1. So I'm just going to go through real quick and go over the answers, so please check them off as you go. So making sure to always draw your line first, I distribute to get 10x plus 75, and then I need to combine my like terms. So over here I have 8x plus 75, which I then want to subtract 75 from both sides. And that gives me 56 equals 8x, and I'm going to finish off by dividing both sides by 8. That would give me an answer of x equals 7 for this problem. For number 2, I want to start off by drawing my line again, and then distributing, giving me 120 equals 5x plus 9x minus 48. And then I want to combine my like terms. 5x and 9x make 14x minus 48. I then want to add 48 to both sides, giving me 168 equals 14x, which I divide both sides by 14, giving me x equals 12 for this one. And then for the last 4 problems, this one gave me x equals 8, negative 8. Number 4 gave me x equals negative 5. Number 5 also gave me x equals negative 5. And number 6 gave me x equals 9. Flip over to the next page and we're going to start taking some notes. So just to remind you, a solution is a value we can put in place of the variable that makes the equation true. To do this, we use our inverse operations, and those are operations that undo each other, like addition and subtraction, and multiplication and division. Those are a pair of inverse operations. So to determine if something is a solution, we plug that value in for x. So I want to plug 10 into the equation for x to see if I get a true statement. So I'm going to do 3 times 10 plus 5. I want to know, does that equal 20? So I get 30 plus 5, which I know does not equal 20. So no, it doesn't make the equation true. So it's not a solution. So that's just something to keep in mind as we go along, because you always want to be kind of mentally checking to make sure your answers make sense. So on the next page, we're going to continue working with variables on both sides. So our goal is to always get the variable on one side and the constant on the other. Since I already have negative 7x alone on this side, I want to add the 2x to get it to the other side. So that gives me the constants on one side and the variables on the other. And then I can solve the remaining equation to give me negative 3 equals x, which again, like on the last page, I can check to make sure it makes sense. 15 minus 2 times negative 3 should equal negative 7 times negative 3. Slide that over. So negative 7 times negative 3. So 15 plus 6 is equal to 21. So I know that I did that correctly. So on the next page, we have our checklist. First we want to, well really we always want to draw our line to start. But then we want to distribute. So I have distribution here. So that gives me negative 4x plus 20 plus 2x equals, distribute here, 12 minus 3x. Then I want to combine any like terms that I have. So I have negative 4x and positive 2x on the one side. That makes negative 2x plus 20. No like terms on the right side, so I leave it. And then I want to get the variables on one side. So I'm going to move 3x to the left side, so the variable is on one side. And that gives me x plus 20 equals 12. And now I want to get the constant to the other side, which gives me x equals -8. So let's try the ones down at the bottom. I'm going to start by drawing my line. I would distribute if I needed to, but I don't have any distribution. I have no like terms to combine, so I want to get the variable to one side and the constant to the other. So to get rid of the variable on the right, I subtract 3x, giving me -4x minus 2 equals 5. And then I want to get the constants to the other side, so I add 2, giving me -4x equals 7. And I divide by -4, which gives me a fraction, -7/4, or if you wanted to write as a decimal, that would be -7.5. It's totally fine to get a decimal for these problems. Okay, so I'm going to try the next one, drawing my line first, and solving for x by distributing first. So I'm going to distribute -5 to the parentheses, giving me 2x minus 5x minus 5 equals 3x plus 1. Now that I've distributed, I want to combine any like terms I have. So on the left side, I have 2x and -5x, which give me -3x. I have to be very careful about the sign here of -5. So I have -3x minus 5 equals 3x plus 1, no like terms on that side. And then I want to get the variable to the left. So I've got -6x minus 5 equals +1, and get the constant to the right. So I add 5, use my inverse operations. That gives me -6x equals 6, and I use the inverse operation of multiplication, division, to solve, giving me x equals -1, which is my final answer for that problem. So I want to kind of give you a visual before we move on to the next topic. So in my scale, I have 4 red circles on each side of my scale. Assuming each red circle weighs the same amount, I'm going to say that both these amounts, 4 circles on each side, weigh exactly the same. So what's going to happen to my scale then when I have 2 blue triangles on this side and 3 blue triangles on this side, assuming they weigh the same? This is going to make this side heavier. When we're solving equations, the 2 sides are supposed to weigh the same amount. So if I wrote like an equation for this one, let's say that each circle represents x. So really, I have 4x plus 2 triangles, and I'm trying to get that to equal 4x's over here plus 3 triangles. That's never going to work. It's never going to be possible because one side, this side, is always going to be heavier than the other. So if I look at this equation, I notice that 4x is the same on both sides. If I subtract 4x from both sides to get rid of it, I'm left with 2 equals 3. That makes no sense. So we would say that this equation has no solutions. It's actually possible for an equation to have no solutions. So if I look at the same scale down here, I'd have to add 1 blue triangle to the left side to make sure that it weighed the same amount on both sides. Just going to get rid of that real quick. So now I have 4 red circles, so I'm going to call that x. So I have 4 x's over here, plus now 3 triangles to make them equal, equaling up to 4 red circles over here, plus the 3 blue triangles. This scale will always be balanced because it always is going to have the same exact thing on both sides. So if I subtract my 4x from both sides, those would cancel, leaving me with 3 equals 3. And so that tells me that this is going to have infinite solutions because I'm left with a balanced scale when I take away the 4 red circles. So on the next page of the packet, we see that there are 3 possible outcomes that we can have. We can have one solution. One solution is when we get a final answer that looks like this, x equals 5. That's just one answer for x. We would have no solutions if we get an answer like we did on the last page with the unbalanced scale, like 4 equals 3. That would make no sense. If it's no solutions, we can use this symbol, a circle with a line through it. And we could get infinitely many solutions if we have an equation like we had on the last page where 3 equals 3. That would mean we would have infinite solutions, unlimited solutions. So let's see how we can get that. If I draw my line here, I don't have any distribution. I don't have any like terms to combine. So all I need to do is subtract my 4x from both sides. And so what happens is the coefficients cancel on both sides, leaving me with 7 equals negative 3. So which of these cases does that look like? Does it look like x equals 5, 4 equals 3, or 3 equals 3? It looks like the no solution situation. So this equation has no solutions. There's no number that's going to work. So we would write no solutions or a circle with a line through it. So what about this next one? If I draw my line, I would start off by distributing. And so I'd get negative 6x plus 12 on this side and negative 6x plus 12 on this side when I distribute. So if I go to get rid of the variable, the 6x's cancel, leaving me with 12 equals 12. If I look back on the last page of my 3 options, that looks like the last one. So this equation has infinite solutions, which is also sometimes called an identity. So let's try the last ones down at the bottom. So we're going to start out by drawing our line and then distributing, remembering that there's secretly an invisible 1 here. So I'm really distributing negative 1. So I get 5. Negative 1 times 8x is negative 8x. Negative 1 times 10 is negative 10 equals negative 8x minus 5. I then need to combine my like terms. So I've got 5 and negative 10 on this side, giving me negative 8x minus 5 equals negative 8x minus 5. I'm going to add my 8x to both sides, and I get negative 5 equals negative 5. So if I look back at my 3 options, it's not one solution, it's not no solutions. This equation has the same exact amount on both sides, so we would say it has infinite solutions. If I look at my next one, I have to start off by combining my like terms. So on the left side, I have 3x plus 4. On the right side, I have 3x plus 5. And if I subtract my 3x from both sides, I'm left with 4 equals 5, which if I look at my 3 options, tells me that this equation has no solutions. It's unbalanced on both sides, so it's no solutions.